Solving trig applications sometimes involves only SOHCAHTOA. You can get away with it if it's a right triangle. That's nice. But when you have a not right triangle, you need to use the law of sines or the law of cosines for it. And each of those requires three things known inside your triangle. You need an angle, a side, and I don't have a third thing. But hopefully you're seeing your way through at least that first part of the problem and you're realizing that this right here, this angle, is supplementary to the angle that's inside the triangle, which in this case is going to be 104 degrees, because these two angles together must add up to 180. Okay, so it turns out I actually do know three things about this triangle. I have two angles, and I can find the third way up top, that angle C that I wrote on the top of the page. That's going to be 3.5, because, hold on, the angles themselves must add up to 180 degrees, the interior angles. So it didn't take us long to find all the angles about this triangle, and what I need now is one of those sides. Remember what it's asking me for. How far is the satellite from station B, which is this distance right here? So it's asking me for that side A that I've marked on the diagram. So when I look at my law of sines over here on the upper right, you notice how I have two versions of the law of sines. They're the same thing. One's just flipped over compared to the other. And I think I want to use the version with the sides on top. You can use either one, and I don't want anybody getting lost over why I used one versus the other. So if you started using a different version than me, that's fine. You just go ahead and do it. But I'm going to use A over sine A equals C over sine C, because I side A, I want side A, and I know side C. So plug in the things you don't know and you know. So that's A over sine of, 72.5 degrees equals C, which is 86 kilometers, divided by sine of 3.5 degrees. Okay, and now a little algebra, and we're going to have our answer pretty quick. We multiply the sine 72.5 over, so we'll get 86 sine 72.5 degrees right there, divided by sine of 3.5 degrees. And now plug that into your calculator. You're going to get, at least I got, A equals 1343.5155. And you know, those go on forever. I don't really care after I have a few of the decimals, but I do want to have a few of those for accuracy. So 1343.5, let's just leave it at that for our answer. But in my calculations, I'm going to continue using lots of decimals so I don't make any rounding errors. Okay, now let's clean this picture up a little bit because I've got a little more work to do. I'm going to get rid of the A, B, the C, all these things I don't need, and I'm going to put in what we just learned, which was 1343.5155. That's that side right there. And now what's it asking us for? It wants to know the vertical distance to the ground. In other words, draw a right triangle. You know the hypotenuse. Okay, you know this angle right here, and what we're trying to find is, let's call it x, or you can call it y. Y might make a little more sense, it's vertical. So we're going to call that y. So if I set up a SOHCAHTOA type equation, that's going to simply be, let's see, I think y is opposite from the angle, right? This over here, this is my opposite. So that's going to be SOHCAHTOA. So that's sine of 76 degrees equals opposite y divided by hypotenuse, which is 1343.5155. Okay, which means now we multiply that denominator over and we get y equals 1343.5155 sine of 76 degrees. Plug that through your calculator. You're going to get y equals 1303.6 according to mine. 1303.6. And that's that. So it's really a law of sines combined with a right triangle application. You're going to see these pretty often. Okay, I think there's a mountain problem running around in the homeworks. That'll be similar to this.